Hi guys, welcome to our third video in chapter 22. This video is going to cover section 22.3, alkenes and alkynes. So you can see our objectives here, two new vocab words, alkenes and alkynes, and we really want to be able to compare, describe, name, and draw these things, okay? So that's what we're going to get started with here. Now, alkenes is our first topic, right? And the En right here, the E is what's different from alkanes. These are unsaturated hydrocarbons and they contain one or more double bonds. So an alkene has a double bond. And you can find these guys on the homologous series chart where they have a formula of CnH2n. The most commonly used alkene is ethene, also known as acetylene, which is used in torches, and this is C2H4. Notice we have twice the number of hydrogens as carbons. So we have two carbons, so C2H4. Okay. And we can see that even for things like 1-butene. Okay. 1-butene being where we have our 4 carbons, 8 hydrogens, because the double bond takes up some space. And that is different. You can see these are not the same, right? 1-butene and 2-butene are different. These have the same exact molecular formula, C4H8. They have, however, drastically different melting points and drastically different boiling points. So there must be some difference between these two molecules. They are not identical. Okay. And the difference is where their bond is. It changes quite a bit about their physical properties. So when we're trying to name alkenes, we actually use them using the same convention as alkanes, except we replace the ane with ene in the end. So, we go from propane to propene. We add the ene here. We also always number so the double bond is at that lowest number carbon. Remember, we're always going to be trying to name these things with the lowest numbers possible. So that's our priority here. Even if we have substituents on our carbons, we're on our group, we will name it so that our lowest numbered carbon is where our double bond is, okay? Now I have over to the right here, I have an example of butene, and we can see 1-butene, right? If I number my carbons, 1, 2, 3, 4, I've got 1-butene here, totally correct, very good. And if I have a double bond on the second carbon here, if it's between the second and third, well, that is 2-butene, also good, gives me the check mark. If I go to our third carbon, right, for a bond between the third and fourth carbon, well, that actually would be wrong for me to call that 3-butene. Instead, what I should do is renumber my carbons. And notice this last one has a renumbering. So that double bond you actually can see is on the first carbon, and we're back to 1-butene. Okay. So again, just making sure that we are naming these with the double bond on the lowest numbered carbon. Okay. Let me erase a little bit. This is a little messy. So additionally, in terms of cyclic alkenes, like you can see this, we have a 1,3-dimethylcyclopentene right here. Cyclic alkenes are named so that the carbon number 1 must be on one of the carbons connected by the double bond. So you can see here, that's this first carbon here. So it would be 1,3-dimethylcyclopentene. Okay. And the reactivity of these alkenes is actually really similar to alkanes. They react very similar to alkenes, except they're actually more reactive at that double bond site. Okay. Also, they're very useful for making polymers, right? So they're a little more useful for reactions. They're very useful for polymers. Things like polyvinyl chloride, right? PVC can be made from the monomer vinyl chloride, which is a 2 carbons double bonded with a chlorine, a substituted alkene, right? Can be used in a reaction to use that as our repeating unit and build out a polymer called vinyl chloride. Now, if you're interested in that, you should study chemistry at the college level because you'll go more into that if you take an organic chemistry class in your sophomore year. But we need to move on to a new class of compounds called alkynes. And you guessed it, the difference is, again, it's the number of bonds, right? Unsaturated hydrocarbons that contain one or more triple bonds. Now, alkynes are less common and they are triple bonded substances. So we have an example of ethine right here. So there's our ethine right there, which is C2H2. Okay, so ethine. And you can see it's named using the same conventions as alkanes, except we throw ane, we replace ane with yne, with Y-N-E. Okay, so we replace that with Y-N-E. These things are extremely similar to alkenes and alkanes, except they're even more reactive, right? We have that triple bond site, so they're even more reactive. So reactive, in fact, that they are often highly, highly flammable, and we have to be worried about making sure that these things are not going to light on fire. And again, they can also be used for polymers. All right, guys, thank you for listening. That's all I have for this video. I'll see you in the next one.